All right, so we're starting limits today. This is all stuff you've seen before, so it shouldn't be anything new. But just to review, since it's been a while. So think about this, look at this equation or function and decide why is it not defined x equals 1? And once you've done that, what does f of x or the function approach as you get close to 1? All right, so here you're not defined at x equals 1 because you can't divide by 0. So the bottom or the denominator would be 0, and that's not allowed. What does it approach? You're going to approach about 2. So how you can figure that out is you could graph it, or if we rewrite this, you can factor the top and get x plus 1, x minus 1, x minus 1 here. These cancel and you're just left with this. So if we have x plus 1 left over, you can plug in 1 and get 2. So limits, what's the notation? This limit here, or this would be said as the limit of f of x as x approaches a is L. So this part is your function. This a value is what x you're looking at or you're interested in. And then the L is the y value as you get close to your x, or close to that a value. So the example here, this is the one from the last slide. The limit as we approach x equals 1 of this function is 2, because y would be about 2 if you graphed it and looked at the graph. So looking at a graph, here we want to figure out what's the limit as x approaches 2. So looking at that value right here, always to figure out what are we looking at. We're not looking at like something over here. We want to look at right here at x equals 2. What is y? So from one side, from the other side, we're at 1. So your limit is 1. All right, this one. First, it wants to know what's the actual value of the function. So where's the closed-in circle? What's the value you would get if you plugged in a number? So at -1, the filled-in circle is right here at 3. The limit then is just what you're doing when you get close to -1. So getting close to -1, we're right here. Getting close to -1, we're right here. So the limit is 1. All right, what about a piecewise? So here we want to look at when f is 0, what's the closed in? We'd get -1. And then if we want to figure out what's the limit, if we come from one side, we're at -1. If I come from the other side over here, we're at +1. And those are not the same. 1 does not equal -1. So your limit does not exist. So you have to be the same thing coming from both sides to get a limit. So that's the summary lesson here. The limit only exists if you approach the same value from the left and from the right. Okay, so these two, graph them in your calculator to get a sketch, and then think about what the limit would be. All right, so if we sketch this, you go back to our 12 basic functions from the beginning of try 1. This function is going to look something like this. And if we're looking at when x is 0, this end is going to go up to infinity because it just keeps going. This end goes down to -infinity. Those two are not the same, so your limit does not exist. This function is going to look something like this. So again, if we look at 0, this end is going to infinity. This end is going to infinity. They're going to the same thing, so this limit is infinity. So just a note, this is what you should do. You should have the limit being infinity. That's what you want. But technically, like in a real life situation, infinity is not a real number. It's a concept. It's the idea like always getting bigger. So really this doesn't exist. Like if you're building a bridge and you got the limit of infinity, you can't have a bridge of like an infinite length or something like that. So the limit doesn't technically exist, but writing it like this is what you should do because it tells us how it doesn't exist. Are you going to two separate things? Are you going the same way? What's happening? So it gives you more information than if you didn't. Okay, so now looking at this function, first of all, does the limit exist at x equals 1? So right here, does the limit exist? The answer is no, because we get one number up here and one number down here. So approaching from the left or coming from the negative side or from the left, we're going to get -2. And if you come from the right or the positive side, you're going to get +3. And that brings us to one-sided limits. So if you look right here and right here, that's the only difference from our general formula or notation for limit. If you have a little negative right here, that means you're coming from the left or the left-hand side, and the plus means you're coming from the right-hand side or the positive side. So they're one-sided limits. So instead of looking at both sides of the function, what's happening, you're looking at just one side. So an example here is this one. So if we're looking at this first one right here, we're looking at when we're approaching +1, so +1, from the left, what value are we getting? You're getting 4 for your y value. This one, we're looking at 1 still from the right. What value are you getting? -2. So then overall, you're looking at what's happening to both of them. You're getting 4 and -2, so this does not exist because you're getting two different values. Okay, so sketch these again, and we'll go through the limits. Or I'll sketch them here. Okay, so this first one should look like this again, and the second one is going to look like this. So at 0 for both of these here, we're going to go up to infinity. So this one is infinity. This one at 0, we're going towards 0. A couple more. If I sketch this one, you get something like this. This one is going to look like this. Use your pi over 2, and this would be pi over 2 right here. And then this, we sketch it again. So for the tangent one, at pi over 2, we're going to positive infinity and negative infinity. So this one does not exist. Here, I forgot to mark it, but right about here is 3. So if we're looking at pi over 2, we're coming here to this point, which is at 3. So you can graph limits to get an idea of what they look like. Check out on Schoology for your homework, but that's it for the notes.